Welcome to the 2020 MAT question 1D. The question asks us to find the largest value obtained by the expression 3 cos squared x plus 2 sin x plus 1. It gives us the options A 11 fifths, B 13 thirds, C 12 fifths, D 14 ninths, and E 12 sevenths. Pause the video and have a go at doing this for yourself. Please note that it is not necessary to differentiate this expression in order to find its largest value. Okay, so our expression has a mix of cosines and sines. Is there any way we can rewrite this so that it only has one type of function in it? Well, indeed, we have a cos squared term, and we can use the Pythagorean identity, which is cos squared x plus sin squared x equals 1, in order to rewrite this expression, because cos squared x is just 1 minus sin squared x. So therefore we can see that this expression is the same as 3 minus 3 sin squared x plus 2 sin x plus 1. Now we can group the 3 and the 1 together to get 4. So we see that the expression is equal to 4 plus 2 sin x minus 3 sin squared x. And we want to find the largest value obtained by this expression. Now, as I said earlier, we don't need to differentiate, so what can we do? Well, this is just a quadratic expression in sin x, so we can use the method of completing the square in order to find its maximum value. So how do we do completing the square? Well, firstly we need to factor out the coefficient of the squared term, which is minus 3. So we can write this as 4 times minus 3 times by sin squared x and then minus 2/3 sin x, because minus 2/3 times minus 3 is 2. And then we half the coefficient on sin x and write this as the square of sin x plus that coefficient and then minus the square of it. So we write it as sin x minus the third squared minus the ninth. That's the same as what's in the brackets here. That is the typical completing the square step. And now what can we do? Well, we can multiply everything inside these brackets by this minus 3. And we can group together the 4 and the third as constant terms. And we see that our expression is equal to 13 over 3 minus 3 times sin x minus the third squared. So this is the full completed the square version of this expression. So why is completing the square useful? Well, we can see that whatever's here, because it's being squared, is always greater than or equal to 0. So in particular, minus 3 times by this is always less than or equal to 0. So therefore, this expression is always less than or equal to 13 over 3. And in fact, we can have it be equal to 13 over 3 if sin x equals a third, which is a possible value that sin x can take. So therefore, we can conclude that the largest value which can be obtained by this expression is 13 over 3. And we see that that's on our list as option B. So our answer is option B, 13 over 3.